Hi everyone, I'm Xinyu from Shanghai Jiao Tong University. Today I'd like to share with you the research on the eye design of social robots. This work is done with Xinguo Zhang, Zinan Chen, Zhanxun, Zhenyu, and Danni Chang. Nowadays, social robots have been widely used in our daily lives, playing the role of human companions or assistants. Similar to human-human relationships, trust is also crucial for developing a great relationship in human-robot interaction. In conversation, eyes can naturally draw people's attention and can effectively express a robot's personality. Therefore, how the robot's eyes are designed may greatly affect how reliable it is perceived. But the robot's eye design in listening state has not been well explored. In this work, we want to understand whether and how the design of a robot's eye features in listening state affects people's trust in them. By reviewing related works, we hypothesize that, in listening state, the robot's eyes with more human-like dynamic features may contribute to a better trust relationship and communication experience. We performed hypothesis testing to address this question. Specifically, we proposed three hypotheses. First, robots with eyes of high-level visual complexity are considered more trustworthy. Second, within the proper blink rate range, robots with lower blink rates during listening tasks are considered more trustworthy. And third, robots with gaze aversion behavior during listening tasks are considered more trustworthy. This work includes a pilot study and a formal study. In the pilot study, we created an online survey that was completed by 180 participants to identify the important factors in eye design during a human-robot conversation. Our hypotheses were based on the result. At the same time, two levels of blink rate were selected for the formal study. In the formal study, we recruited 62 college students to participate in the Wizard of Oz experiments to test our hypothesis. To do so, we developed a test system consisting of a physical robot prototype called eBot and a backend control website. A mobile phone is embedded in the face of the physical robot prototype to present animated stimuli to participants. A voice module is placed inside the robot. The web backend is used to send commands to eBot to remotely switch stimuli of robot eyes and play voice feedback to control the experiment process. Based on the three variables, we organized three groups of experiments. For experiment group A, there are three levels of visual complexity. The higher the visual complexity of the eyes is, the more features they contain. For experiment group B, there were two levels of blink rate, 20 blinks per minute and 10 blinks per minute. For experiment group C, stimulus C1 has no gaze aversion, while C2 has. The gaze aversion is realized by adjusting the absolute position of the pupil, regularly from the center to a random position of the sclera. All the animated stimuli are created with CSS and HTML. During the experiment, participants were asked to make a conversation with eBot on a given topic and then complete the trustworthiness perception scale. The scale evaluates trustworthiness by three subdimensions: ability, benevolence, and integrity. Participants were required to repeat this process multiple times until all required tasks were completed. They were also interviewed about their experiment experience. Through data analysis, we found that robots imitating humans' nonverbal behavior may lead to a higher level of perceived anthropomorphic effect and effectively improves users' perceived trustworthiness and user experience. Specifically, human-like eyes with complete structure and rich details might evoke a stronger sense of trust, especially in the benevolence dimension. The robot with gaze aversion behavior was thought to be in the state of thinking, more trustworthy and stress-relieving. Blink rate has a non-significant influence on trustworthiness, but also affects user experience. The dynamic blinking of robots is needed to enhance a vivid and intimate impression. 4 design suggestions are further generated based on what we learned from the experiment. First, loveliness and vitality are the keys to the appearance design of robots. Second, attention should be paid to the consistency of the anthropomorphic level in robot modeling, animation, and behaviors. Third, smooth and diverse animations within a small amplitude are more suitable for the dynamic behavior of robots. Finally, customization of robot design, such as the eye color and blink rate, is recommended to address different user preferences. These designs can help to increase the user's trust in the robot and improve the quality of human-robot interaction. Through our work, we increase the empirical understanding of how the robot eye design in the listening state affects the user's perception of trustworthiness. And secondly, we identify design implications for robot design, and these help pointing out our further research directions. Thank you very much for your attention, and I'm open to questions.